Hey everyone, as promised, today we're going into the code. We're just gonna start coding this up. Uh, Fair warning. Well, not really warning, I guess, but just letting you guys know. I am just gonna jump right into the code, not much explanation. I mean, if I deviate or whatever, sure. But for today, I'm just gonna go straight to the code, and I'm gonna have another actual lesson video where I also do the summary of what we are doing. So yeah, and I'm mostly just gonna keep this window up to double check my answers and stuff. So I think the easiest way to do it, which I did already earlier today, the reason I'm making a separate lesson video, just FYI, is because honestly, I just want to go over it again myself. Um, but the way I approached it, and I think the easiest way to do it is just to break it down to all the smaller operations you're really gonna need. So let's start with the inner products. We've done that like a bunch of times. It's just the um, oops, A comma B, the whatchamacallit. It's just the dot product, so that's pretty easy. That's sum of AI times BI for I in range and it doesn't matter. Just gonna presume. Actually, I did this a little bit different because normally I just give it a list and then some. This is a generator expression. I wonder if it works with the generator expression. Uh, Product. Let's test out. 1, 2, 3, 4, 5, 6. See if that works. Oh, I have to return it. 32. 4. 2 times 5, 10, 14. 6, 1, 6, 6, 2. Yeah, 32 actually. So 6 times 3 is 18. 5 times 2 is 10. 10 plus 18 is 28. 28 plus 4 is 32. Yeah, it is 32. So this works. I can just give it a generator expression, which is nice because it just removes a step. Well, anyways, our product, this one was a little trickier. So return some. Oh, I misspelled out our product. And there's no sum. I don't know why I'm doing sum. So it's going to be two lists. A underscore n times B underscore n for A underscore n and A for B underscore n and B. Is that correct? Well, let's just find out. I believe it is. One times four. One times five. One times six. Wouldn't the first row be 4, 5, 6? Why is it 4, 8, 12? Right, the first vector is 1, 2, 3, and 4, 5, 6, so it's 1 times 4, 1 times 5, 1 times 6. The 4 is correct, but this doesn't seem right. I think it's the other way around, actually. That makes more sense, actually, right? Because A will be done multiple times before the loop iterates into B. Yeah, okay. Yeah, that's correct. There you go. 4, 5, 6, 8, 10, 12, 12, 15, 18. There you go. That's correct. Um, let's see. What else? I'm gonna scale vectors. Well, let's just get identity. Get the identity matrix. Shape. Um, one moment. Gonna get a little comfortable. I got one of those chairs with a built-in footrest. Just gonna ease into this one. Ooh yeah. Okay, so we're gonna return a nested list essentially. Honestly, we could replace most of this with tuples, but whatever. I'm lazy. And with tuples, if you're not careful, you could evaluate a generator expression into a you just end up passing the generator expression off, and so because you have to call tuple on the generator expression, because if you just cover the expression in parentheses, it's just the expression itself. So anyways, whatever. Tuples. Having fun with tuples. 2 tuples, 3 tuples. I like that word, tuple. Alrighty. Get identity 0 if I not equal j, else 1 for I, no, for j in range shape, for I in range shape. Let's get an identity matrix, test this out. 1 0 0 0 1 0 0 0 1. Yep, correct. A little bit of new little zhuzh. Let's do embedding of matrices, which we will have to do at some point. You know, let's just do an easier one first and scale vectors m comma v, return m times n for n in v. That's easy. We also got to scale matrices. Something I forgot when I was doing this by myself, and I got hit with a bug, and I was like, what is going on? M comma big M to signify a matrix. Gonna be a nested loop. Return M times N for N in row, for row in M. There you go. We're gonna have to do the L2 norm. Of a vec, which is And here we can skip the. Here I want to note that I did 0 if I not equals j because I'm short circuiting. Basically, this is going to be true way more often than the else, especially if you get into arbitrarily large shapes. So better to get that 0 in rather than doing a check for if I equals j. So just a little thing, because I did not do that when I was doing it myself. So anyways, sum, well, whatever the sum is, we square root it. So let's just do that. And we're looking at square for n in v, right? So it's the sum of the squares and then square root. We're gonna have to normalize vectors. So v, some vector v would be scale 1 over L2 norm v comma v. Oh, I forgot to return on this. Scale vec, because we have a secondary scale function. It's probably something I'm forgetting. Let's talk embedding of matrices. How do we do this again? For I in range len A, I'm gonna have to do some sort of slice assignments. I negative I, right? So the last row. Shape colon equals. Just gonna do some slice assignment where it's shape colon shape minus 1 through to the end equals a negative I, negative I. Now this technically does it in place. So I'm just going to return I because there's some code later on that made it easier, but whatever. I'm going to test this one out. Embed matrix, get identity, let's say 5. And let's get 1, 2, 3, 4. Oh no, this is bad. This is really bad. Jesus Christ. What have I done? Is this the correct one? No, that doesn't make sense either. No. I negative I, so start with -1. And I do -I colon. That doesn't seem right. No. From some starting point, right? Because then this is just -1, right? Shape sounds about right. Or should we do negative shape? -1 to get the indices right. Nope, that did not work out either. Maybe it's just negative shape. I think it is just negative shape. Yeah, no. I minus I, so the last row. Take, no. This is not 0, 0, 2, 0, 0. No, this isn't right either because it's not square. Man. Oh, len A0. That should work. And it did not. The 1, 2 disappears into the ether. Nope. Why is so I -2? I'm gonna look at what I did earlier. I'm not gonna lie. Fuck it. Is this the correct one? No. I don't understand why this is correct. Why does this happen? is confusing to me. And this is exactly what I did too. Oh, because it starts with -0. Duh. There you go. That makes sense, right? Oof. Shit. Yeah, that scared the piss out of me. My niece and nephews are in, so I was like, what's going on? Is everything okay? Concerned uncle look. Okay. Um, just gonna look here and see. You know what? Instead of looking here, I'm gonna look here. Yeah, let's do matrix subs. Mat sub. Let's also get basis vectors, which we will just take unit vector for. Return zero if I not equals one. So it's one for and range shape. Zero if it's not zero, if I is not zero, okay, the index is not zero. Also gets me that. So let's just test it. Yep. All right, that's fine. Let's do matrix sub. Okay, this one is a little harder. Some sort of list comprehension. For J in range. Oh, okay. I heard that. I freaked out for a moment in the middle of video. I'm like, oh, what happened? What's up, guys? You want to say hi to my wife? Want to come and say hi? Okay, my wife doesn't want to say hi to you. You fucking nerds. Yeah, I did. These guys are fucking nerds. They're fucking watching a video about a guy doing householder reflections in code. Nerds. Okay. For J in range I. I told myself I thought like smoke in the bathroom. Um, Never mind, video's ongoing still. Are you okay though? Are you hungry? Do you want to order something? Okay. Oh, baby. It's okay, soon Didi will handle it throughout the night. Yeah, I get it. Hmm. Okay. Going through all the I's and the J's correctly. So it's just gonna do that, minus I, J. Alrighty, let's test that out. Math sub get identity. Everything okay, babe?
Yeah.
Okay. I told you, babe, you went out multiple times today. You walked for a while, plus you spent a bunch of time in the kitchen. Makes perfect sense to me. Does this make sense though? 1 minus 0 is 0. Yep. 1 minus 2, sorry, 0 minus 2 is minus 2. 0 minus 3 is negative 3, and 4 minus 1 minus 4 is negative 3. Yep, okay. Math sub is also working. Let's see what else. Okay, outer products. Normalization. Let's see if we got everything for building the householder reflector. Okay. X equal, okay, normalization. Sorry, the norm of the vector, got it. Alpha, that we can do very quickly in code with what we have, because we have the scale. Well, we have the L2 norm, and then we have the getting of the basis vector. Do we have a vector sum? No, we don't have a vector sum function, so let's just do that really quickly. Honestly, we could cheat with the get basis vector thing. In the main video, I'll probably do that cheating instead of here. Here, I'm just gonna stick with what I already did today and know works. So, vec sum a comma b colon return. Make sure I'm returning in everything. Yes, I am. Return ai plus b I for I in range when there you go. That's, I'm not even gonna test that out. That's pretty basic. And then the reflector block itself. I have outer products, I got scale, I got everything. All right, let's do the reflector block. Get reflector. That's gonna take essentially a vector, right? Because you're just gonna take the vectors repeatedly. Getting the reflector. So we have a vector v. We should call something else because I'm gonna make you and it's x. Let's call the vector x. Makes more sense. So first thing, we can go straight to alpha. So alpha equals the sign of the first element of x. So that would be v0 divided by the absolute value of v0. That gives you the sign of the first element of, oh, not vx. 1 second, babe. What's up?
How much time?
I think we're closing in over here. We're closing in. बबी मुझे चाहिए बबी को चाहिए मैं आऊँ मेरे कोई व्यूअर्स नहीं है कोई नहीं देखने वाला मेरे वीडियोस को 10 साल बाद फिर लोग देखेंगे बोलेंगे हाय अपने बीवी से कितना प्यार करता है Hmm. Okay, so alpha is this, right? So the sine times the L2 norm, right? Yeah, times the L2 norm of x, right? So that's alpha. And then u is x plus alpha e1. U equals uh spec sum scale. So I'll just do x comma scale alpha get basis spec when x. Let's do that. Scale spec. Okay, phi equals the normalized version of phi of u, I mean. Normalized back on the, yeah, okay. And then I need scale to outer product v comma v. Okay. Scale mat. And then we mat sub I minus that, right? Yep. Get identity on x. Actually, let's just, instead of doing 1x twice, we'll do shape equals len x. And then wherever I use len x, like over here, shape. We'll do shape again. I'm doing mat sub. Oh, why did I do that? It's a function. And that's the end of the reflector block. The rest is the embedding and then this. I could just embed it. No, I'm just gonna return this, I mean. And just test this code out. Get underscore, oops, sorry, no. Get underscore reflector. We're just gonna do 1, 2, 2, because that's the example we've been working with. Negative 0.33, negative 0.66, negative 0.66, negative 0.66, negative, not negative, positive 0.66, negative 0.33, negative 0.66, negative 0.33, 0.66. Oh, wait, sorry, I just realized something. Is that supposed to be negative 0.866? No, it's supposed to be positive. Oh, okay. All right, I am going to call it now on the video because we're doing the reflector fine, because I just realized there's a bug in my tri-diagonal script because I got it mostly right, but the sign isn't quite right. Like over here, it should be 0.86, but it's a negative 0.86. It's 861,386. Yeah. And I just realized that because I had a round. Yeah. How do you have -0? That's crazy. Oh, that's because the value is negative. That's fine. Hmm. Anywho's, we're just gonna call that today. Remember, everyone, just to stay curious and keep on keeping on. Like this one was a toughie for me. I feel like, and I think I had come up against the bedrock, if you will, or the intellectual bedrock, or like the understanding bedrock earlier, multiple times for this one, and then I managed to push through it, and I mean like not just in the sense of um doing it here, like in the process of like building the lesson 11 episode, which is why I've been calling this On the Road to Lesson 11. But actually, even before it, like when we went into Lebesque spaces and stuff like that, I felt like we touched this before, and I wouldn't say I've fully broken through and fully understand what's going on, but I'm understanding quite a bit more, so I'm happy about that. And yeah, learning, it requires effort, but not the way we think. We think, oh, you need to be disciplined and working 24/7 all day. And like, okay, today and yesterday I did like parts of this week and earlier on when I was doing these videos when they first started coming out, when I first started putting them out there, it was working all day every week, but I kind of alternate like every week or so. Like, I mean, the week before this one, I was like mostly like just like chipping away at it in small amounts, right? And it makes a huge difference because if I had just been like, oh, I'm not looking at this at all for this week, it would have made it way harder. Like I feel like I would not have hit this point so far. I think at best I would have gotten to where I was like 3 or 4 videos ago. Um, so yeah, and probably even less than that, to be honest. I think some of the reason I could make this much progress on the household reflectors was because I spent so much time, um, like really, like time in the sense of like coming back to it every day and giving myself space in between sessions, right? Um, allowing myself to goof off a little bit or think about other things in my life. So yeah, it's important, man. Don't simply just don't give up. Just keep coming back to it. You don't have to come back to it and be like, "Roar, I'm the best. I'm gonna do like 12 hours. I'm gonna just keep learning this until I get it. Yeah, I'm such a Chad." No, you don't have to be that way. You just need to come and like look at it. Really. That's where it starts. Just keep looking at it. Anyways, that's enough of my philosophy. Have a great one, everyone. Goodbye.